Now we will start to simulate a simple case to understand how to use the Aspen HYSYS software and to know also what Aspen HYSYS software can offer us to do. Okay? Now I will start to share my desktop. Do you see anything? Okay. Now it's supposed that you are seeing the flash separation example. It's from your workbook. Okay? You can find this example on page number 1. Okay? Now I am showing you the PDF file flash separation. Example on the workbook. This is page 1. Page number 1. Okay? Now we will start to use the Aspen HYSYS software to simulate this case. Now we have a stream containing 15% ethane and 20% propane and 60% isobutane and 5% normal butane at 50 degrees Fahrenheit and atmospheric pressure. These are the conditions of the feed stream. This stream is to be compressed to 50 psi and then cooled to 32 degrees Fahrenheit. There is a delta B inside the cooler. The delta B is 10 kilopascal. Due to cooling to 32 degrees Fahrenheit, there is some of the vapor condensed. So I have to separate the vapor from liquid by using separator. I'll use the fluid package Bang Robinson, and then I need to calculate the following. I need to calculate the heat duty rejected from the cooler per hour and the compressor horsepower, and I need to calculate the stream composition for both vapor and liquid streams coming out from the separator. This is the first thing. I'll show you how to simulate this case. Okay? Do you hear me? Okay. Now I'll open the HYSYS simulation software. We have here Aspen HYSYS version 8.6. If you have an older version of HYSYS, okay, no problem, but it should be version 8.x. It means that you should have version 8, version 8.1, version 8.2, version 8.3, any version, but it should be version 8 because the interface of version 8 is completely different from the other versions. Okay? Now, when you open the HYSYS, this window will appear. Now I'm sharing the Aspen HYSYS software with you. Yes, this is the first example. Okay. Now, now I need to start the new case. So I should click here. I should click on the new icon, or from file menu, from file menu, I can find the new icon here also. From press new and then select case, file, new case. Or you can use a shortcut Control plus N to create the new case. Okay, new case. After pressing new case, this window will appear. I'll prepare my simulation case. Okay, there is two things to do before entering simulation. First, I have to select the components. First, I have to select the components. So I'll go to component lists. I am already here. And then click add. I am in component list. And then I'll press from the right hand side. There is a button, add button. Okay. I'll press add. As you are seeing now, there is a full list containing all the components I need. There is methane, ethane, propane, isobutane, normal butane. All the components we are using in oil and gas simulation, you will find here. Okay. All I need that I have to select the components of my case only. I have to select the component from the entire database. This database contains all the components I need, so I'll select only these components I'll use in this simulation case. Here I have ethane, propane, isobutane, normal butane. Select only these four components: ethane, propane, isobutane, normal butane. How to select? Just click on the component from the list and then click add. First, I'll click add button. You see here, add button, transfer the component from the database or from the list to the selected components that I'll use. Now ethane is successfully transferred. Okay. Now I'll select the other component by the same way. Propane, I press add, and isobutane add, and normal butane add. Here I have only four components, so no need to add more components. Only I have to select my components, my simulation case components, or my plant components. So I selected here these four components. Each component from these components containing all the physical properties. You can check, you can double click on any component after selecting it, of course. You can press double click, okay, on ethane, for example. this window will appear. Here I can find ID for the component, its hydrocarbon, and its chemical formula, it's C2H6. And I can find also the critical tab from the top. When you press on the critical tab, you can see here and the normal boiling point and the ideal liquid density, all the physical properties for this component. So it's not just a name. Every component is fully defined. Okay? You can use HYSYS for only to check the normal boiling point for any component you need. Sometimes I'm using it for purposes like this. Okay? Now, if I want to exit from this window, just close it. Any, if you want to exit from it, just close. Okay? Now, I select the 4 components. Okay? Now, as I told you before, there is 2 things to do before going to simulation. Okay? There is 2 things to do before going to simulation. First thing is to select the components. Second thing is to select the fluid package. Now we have to go to fluid package from the left hand side menu. You will find fluid package. I have to select Bing Robinson. So I'll go to add bottom and press on it. Okay. And then select the suitable fluid package for my simulation case. Now, this here he said that I should select fluid package Bing Robinson. So I'll select Bing. Okay. Yes, Bing Robinson is most oil and gas application. Okay. Why? Because Bing Robinson is suitable with wide range of temperature and pressures. Okay. Now, here in this case, I select the Bing Robinson, but I need to know how to do this selection. Why I already selected this fluid package. Okay. Now there is, you see here, there is a bottom called Methods Assistant on the top. You see, there is a bottom called Methods Assistant on the top menu. In this ribbon, we will find Methods Assistant. Okay. This tool helps me to select the proper fluid package for my case. Okay. Now, if I press on Methods Assistant bottom, this window will appear. Okay. If you select the Methods Assistant bottom, this window will appear. Okay. Sounds clear? Do you hear me? Okay. Okay. Now, why I open this was I need to know how to select the fluid package. Not only the fluid package, I need to select that suitable fluid package for my simulation case. Okay. So how this window appears again? First, I have to click on Methods Assistant. Okay. This tool will help me how to fluid package. Okay. I'll press Method Assistant again. This window will appear. Okay. Here he's saying that the assistant will ask you which it uses to suggest one or more probability. Okay. He will ask me some questions and it will guide me to select the suitable fluid package. Okay. Now I have to click next. I'll click to this next arrow. Okay. Here he is asking, I want to specify component type or specify process type. Not all the fluid package is suitable with the all components. Some fluid package is suitable for hydrocarbons and some is suitable for electrolytes and the others suitable for amines. So maybe I can select depending on the components or depending on the entire process. Here I'll select specify process type. Here I'll select specify process type. Okay. He's asking again. He's asking me again which type of process or application I have. If I'm dealing with oil and gas processing, I have to select oil and gas processing. If I'm dealing with petrochemical, I'll select petrochemical. Okay. Now I'll select oil and gas processing. I'll select oil and gas processing. Now here is the answer. He's saying that the Bing Robinson or SRK is suitable for oil and gas processing. Okay. You can use this assistant to help you how to select your suitable fluid package for your case. But for this case, Bing Robinson is suitable for my case. Okay. Now I'll close the assistant tool. Okay. And to confirm that I have already Bing Robinson property package. Okay. Fluid package or property package means the equation that the HYSYS uses to calculate the properties of the streams. So if I select improper fluid package, the results will differ from the results in my plant. Okay. So I have to select the proper fluid package to make the simulation case giving me the results like the results coming out from my plant. Okay. Okay, now I am ready to do simulation. After adding the components or selecting the components and selecting the fluid package, now I am able to start to simulate my plant. So I will go to the simulation button from the left hand side menu. I'll find that there is a button called simulation under the properties button. I was in the properties and then I go to simulation. Okay, I'll press simulation. the simulation bottom, this window, this the BFD window that I'll draw my process flow diagram in this white background. Okay, I'll start drawing my plant using this toolbar or this window. This window called palette. Okay, this palette is like it contains all the equipment that I need to see. Okay, here I can find uh, separators, heat exchangers, air coolers, compressors, pumps, expanders. Okay, here I find everything. Okay, there is two streams. Here you can see the material stream. It's the blue one, and there is energy stream and energy stream. It's the red one. You can see here there is two streams: material stream and energy stream. Okay, material stream is used to define the composition and the conditions of the fluid, and energy stream is used to represent the energy or the power or out from the equipment. Okay, if I need to simulate the compressor, there will be suction line and the discharge line. I represent them using material stream, and there is energy stream representing the horsepower coming to the compressor. Okay, now I'll start by drawing a material stream. Okay, to draw a material stream, all you need to click on the material stream on the palette, and then click on the place you want to draw in the flow sheet. Just one click here and here. No need to drag. Okay, just one click here and one click in any place on the flow sheet. Okay, now I need to define the composition and the conditions for this stream. Okay, to define these conditions, I have to double click on the stream, double click on the stream. Okay, this now I can find that there is a yellow bar on the bottom. You see it? There is a yellow bar on the bottom and containing a message. He's saying that unknown composition. Okay, this will be my guide. This will be my guide. So I'll follow these instructions. This yellow bar we are calling solver. This we are calling solver. Okay, as it solves the case step by me. Now he's saying unknown composition. After completing the composition, he will give me another message. Okay, and he will not leave me till I finish. So HYSYS is very easy to use. Just follow this yellow bar. Okay, now he is saying that unknown composition, but now I am here in conditions. So I have to follow his instructions. I'll not start in condition. I'll start in composition. So I have composition from the left hand side menu. I will go to composition from left hand side menu, and then I'll write here the mole fraction for each component. Okay, he's saying here that this stream is containing 15% ethane and 20% propane and butane and 5% normal butane. So I have to write this composition on this window. But here he is asking for mole fraction, not mole percent. So here it will be not 15%, it will be 0.15 because it's fraction, not percent. So I'll divide each percent by 100 to get the fraction. Okay? After writing 15, I will press enter. After writing any value in HYSYS, you must press enter. Okay? Now another window appears. The other composition here. Now for the propane, it will be 0.2 and then enter. And for the isobutane, it will be 0.6. And for normal butane, it will be 0.05. And then enter. Enter is very important. After each value, I must press enter. Okay? Now, as you are seeing here, the total is 1. It should always be 1. Okay? Yes, isobutane, it is ibutane is isobutane and n-butane is normal butane. Okay? Now the total is 1. Okay? This window, if I want to leave it, never ever close it from here. You should click on OK. You should click OK button. After adding this composition, I'll close this window by clicking OK. Now you see that the yellow bar on the bottom showing unknown temperature. The yellow bar on the bottom showing unknown temperature. So he's solving with me step by step. He's solving with me step by step. Okay. Now I need to define the temperature. So I will go to condition from the left hand side menu. I'll go to condition to write the temperature. The temperature here is 50 degree Fahrenheit. When I start typing 50, I will show another cell to select the unit. No need for conversion table. Just you have to write the value and select the unit. Okay. Now it's 50 Fahrenheit. So I'll select F. Now he convert it to 10 because he is showing here this window in SI units. It's in Celsius. So 10 Celsius equal 50 Fahrenheit. Okay. Now you can see that there is updating. He is updating the status. This yellow bar or yellow status, he is updating and solving with me step by step. Now he is showing unknown pressure. So I'll give him the pressure. Here it is 1 atmosphere. He's telling me that atmospheric pressure. So I'll tell him that it's 1 atmosphere. So I'll write 1 and then select ATM, atmosphere. Okay. Now he calculates the vapor fraction. This stream will be completely vapor. At this condition, at 50 degree Fahrenheit and 1 atmosphere, this composition will be totally vapor. Okay? Vapor fraction 1 means that it's totally vapor. And sure, it's supposed to be totally vapor because it will enter the compressor. Okay? Now he's showing that unknown flow rate. Here I can define the flow rate as molar flow or mass flow or standard ideal liquid volume flow. Okay? Now I have the flow rate with molar base. Okay? So he's telling me that it's 100 pound more per hour. So I'll select molar flow. I'll select molar flow and start typing 100 pound more per hour and select pound more per hour. Now he's showing okay. Okay means that I complete this material stream. Okay, this stream now is fully defined. And all other unknown conditions is calculated. He calculated it by the fluid package that I selected. Okay, now you can see that he calculated the mass flow and the standard ideal liquid volume flow and molar enthalpy and the molar entropy and heat flow. All these parameters and variables was calculated. Okay, it's calculated using the fluid package that I was selected from the beginning. Okay, now he's saying okay, so I'll close the window. Okay, ready to connect it with the compressor. Okay, now he's saying that this stream is to be compressed to 50 beats. So I need to draw a compressor. Okay, so I'll select the compressor from this palette. You can from the palette on the third row and first column from the right. You can see here there is a compressor. Okay, so I have to select it. Just click on the compressor and click on the anywhere you want to draw in the flow sheet. Now you are hearing me well? Sounds clear? it's important to give me your feedback and tell me if you are hearing me. If not, okay. Now I selected this compressor and just draw it here. So I need to start connecting this stream with this compressor. Okay, so I have to do the same. Double click on the compressor. Double click on the compressor. Double click on the compressor. This window will appear. This is the compressor. Okay. Now again, I'll follow the. You are seeing that red bar in the bottom. This is the solver again. Okay, he's saying that there is a feed stream is required or requires a feed stream. Now I am here in the connections page. I am here in the connections page. So all I need here to connect the streams with, I have to connect the streams with the equipment. Okay. Now I need to connect stream 1 to the compressor. Okay. So if it's already drawn, I'll select it from this menu. Okay. If I already draw the stream, I'll select it from here. Stream 1. Now you are seeing that stream 1 is now connected to the compressor. Now you can see that stream 1 is connected to the compressor. Now the message updated. He's saying that requires a product stream. Now I need to know what the name of the discharge stream, the outlet stream. Now he only need the name. Here I can write need. For example, I can write here, okay, and press enter. You see here, he creates a new stream and connected it with the compressor. Okay, he created a material stream, but it's one, of course. Okay, connected it with the compressor. It any stream, just write any name, and he will create the necessary stream. Okay. Now the message updated. He said an energy stream. There is energy stream required to represent the power or the work coming to the compressor. Even it's coming from a turbine or from electric motor, just give him a name. Any name, an energy stream. All I need is to give him a name. Okay? Just type here Q1 and then press enter. Hello again. I was on a phone call. Now I already connected the inlet stream and the outlet stream and the energy stream. Here only what I did is giving him any name, inlet and outlet stream and for energy stream. Just give him a name, okay? Now he's saying unknown duty. Now he's saying unknown duty. Unknown that he needs to know the horsepower, the energy or the duty coming to the compressor. Okay? If I give him the horsepower, he will calculate the pressure outlet. But now I have already the pressure outlet and I need to calculate the horsepower. Okay? So instead of giving him the duty or the horsepower, I'll give him the outlet pressure. And he will calculate the unknown duty. Okay? Okay. How to give this pressure? Just go to the worksheet tab. Just go to the worksheet tab. You see here, there is on the okay. You see here that there is tabs. I'll go to worksheet. Here I'll find every stream connected to this equipment. Okay. Here there is inlet stream and outlet stream and the energy stream. I'll go to the outlet stream, stream 2, and in front of pressure, I write 50 psi. I write 50 psi. Okay, I write 50 psi A. So now I give him the pressure outlet and say showing here that everything is okay. You see here, it's okay. Okay means that he already calculated the horsepower required to pressure the stream from 1 atmosphere to 50 psi. Okay, now he calculates the required horsepower. Where I can find it, I can go to the design tab. Now I'll go to the design tab and go to the parameters. Design parameters. I'll find here the duty required. It's 49.5 kilowatt. And if I move the mouse over this value, not clicking, just moving it over, he'll show the duty in another unit. It's 66.4 horsepower. Now he's showing that I need here a compressor with 66.4 horsepower to raise the pressure from the atmospheric pressure 14.7 psi to 50 psi A. And here he assumes that the efficiency was 75%. I can change it, of course. Now, this is the first thing that I took the horsepower required. It's now 66.4. Okay. I'll continue by closing this window. Now this stream, this two stream, here that this stream is to be cooled. Now I need a cooler stream from the discharge, the compressor discharge temperature to this temperature. Okay, now I need to cool this stream to 32 degrees Fahrenheit. And there is a pressure drop inside the cooler. It's 10 kilopascal. There is a pressure drop inside the cooler. It's 10 kilopascal. Okay. Now I'll select a cooler from the palette. You can find it from the first row. First row and the first column from the right. You can see the cooler. I can select it by click here and click anywhere. Okay. That's it. Okay. And again, I need to connect this stream with this equipment, so I have to go inside the cooler by double click on the cooler and do just following the instructions. That now he is required a feed stream. He is requiring a feed stream. Again, I am here in connections. Just connect. Just I need a cooler, so I have to select it from here. Now I'll connect number 2 stream with the cooler. Now it's already connected. Okay. And then he needs a product stream. He's saying requires a product stream. So I'll go to the outlet and again give any name. I'll give him 3. And again, not just writing the name. It's very important to click enter. Okay. When you click enter, it will create the outlet stream. Okay. Now there is another is remaining. Now he is asking me to give him a name. Only in the connection I am giving him a name for an energy stream. I'll give him, of course not, I'll not give him Q1 again. I'll give him another name. Of course, I'll not give him the same name. I'll give him another name different from the first energy stream I already draw. I'll give him Q2. You see here, it's a simple cooler. Okay. No need here cooling stream or the utility stream to enter the cooler, and it's coming out from the cooler with 32 degrees Fahrenheit and amount of heat, and it will be displayed in Q2 stream. Stream 2 will be cooled to 32 degrees Fahrenheit, and then there is a Q2 stream will represent the duty rejected from the cooler. Okay. Now the message is updated that unknown delta B. He is saying that unknown delta B. So now I'll go to again to parameters. I'll go to parameters and give him the delta B of 10 kilopascal. You see, I'll go to parameters and give him 10 kilopascal. without the solver or without this yellow bar, I can't do anything. Okay, so I have to follow this yellow bar, especially for beginners. Maybe after that you'll not look to this yellow bar every time. Okay, now delta B is okay, and then he's showing that unknown duty. Again, he need of duty rejected from the cooler. So I'll give him the duty rejected from the cooler, or instead of it, I give him the outlet temperature, and he will calculate the duty required or the duty rejected from the cooler. Okay. Here I have that outlet temperature. Instead, so I'll go to worksheet again. I'll to worksheet, go to worksheet again, and then in the outlet stream, this its name is 3. I'll go to temperature and then write 32 degree Fahrenheit. 32 degree Fahrenheit. So it's showing that it's equal to 0 Celsius. Okay. Now, as you see here, the inlet stream was in with vapor fraction of 1. Okay. And then due to this cooling to 0 degrees Celsius or 32 degrees Celsius, okay, most of this stream is condensed. And now the vapor fraction will be 25%. Okay, so now the vapor fraction will be 25, and the other 75% is now liquid. Okay, so now there is a vapor and liquid in the stream, so I have to separate liquid from vapor. So I'll close this window and go to the separator, and then anywhere inside the separator to connect stream 3 to the separator by double click on the separator. Tell him that the inlet stream is here. There will be two outlet streams. It's vapor and liquid stream. So I'll tell vapor stream, or I can write 4 and 5. It's a vapor stream and there is a liquid stream. You see? It's okay. Here, energy stream is optional. No need to install energy stream in most separators. Only I'll need this energy stream maybe in reactors. Okay? So here, energy stream is not required. Okay? Because I am not usually using heating jacket or heating coils inside the separator. It's only applicable when I am using reactors. Okay? Now, it's suppose that the composition and conditions for the two outlets. So I can find this composition on the worksheet tab, and then go to composition, worksheet, and then composition. I can find that there is a material balance is done on each stream. There is a liquid and vapor stream containing the composition for each component: ethane, propane, isobutanol, butane, in the liquid and vapor. You see, most of the ethane is coming out from the vapor stream. Okay, it's very easy example. It's very easy example. Now, all I did is just simulate. Okay, Now I am just simulating the case, but till now, there is only using the simulation. There is a lot of tools in HYSYS I can use to enhance this simulation. I can and I can do case studies. I can adjust any condition by the HYSYS tool. But first thing, I have to simulate my plant. Okay? Okay. Now, workbook, the table, you can see that he is asking me to create a case study to see the effect of changing temperature of the stream on the molar flow of the liquid product stream. Okay, asking me to create a case study on the HYSYS to see the effect of changing temperature of the cooler out stream. Now, this cooler out stream here is stream number 3. I'll change the temperature of the stream 3 and see the effect of this see this change on the liquid flow rate coming out from the separator. Okay, of course, if the temperature of stream 3 increases, you see here, if the temperature of stream 3 increases, the liquid flow rate decrease or increase? I'm asking. Okay, right. Okay, here this case study is simple. Okay, but I need to know how to create case study. Okay, but I know the results before I made this case study. I know the results. Okay, but I'll do this simple case study to see what can HYSYS offer me. Okay, now to do this case study, I'll go to the home menu from the ribbon. I'll go to the home. You can find that there is analysis on the right. Okay, you can find that there is a button called case studies. There is a button called case studies. It's here. You see, it's here. I have to select first home, okay, and then go to the right. I'll find that there is a case studies. Okay, I'll click on the case studies button. Now, a new tab. He made a new tab called the case studies. If I want to go back to the flow sheet, I can to I can select, click here to the flow sheet, and then if I want to go again to case studies, I can click here to case studies. Now he's making tabs like Box or Google Chrome, any browser you can see the tabs. Okay, now I am in case studies. I'll add a new case study by pressing add button from the bottom. I'll press add. Okay, I'll press add. Now he's showing case study 1. Now I have to tell him the two variables that I want to study the effect of one of them on the other. Okay, I want to define the two variables. I want to define the two variables that I want to see the effect of one of them on the other. So I now select the temperature of stream 3 and the molar flow of the liquid stream. Here the temperature of stream 3 and the molar flow of liquid stream. So I'll go again to case study and add these two variables. Press add and first select object here or equipment, a stream or equipment or an equipment. Okay, so I'll select stream 3 and I need to select the temperature variable. So I can click on any variable and start typing temperature and start typing the first letter T. Now he will take me to the temperature. Okay, I selected the object 3 and then go to temperature. This is the first variable. I'll click add. Now you see on the now the first object is 3, variable is temperature. Now I need to see the effect of changing the temperature of stream 3 on the molar flow liquid. So I have to select another object. Now it's liquid of the another stream. Now it's a different value. I need to select molar flow. So I can write M. And I'm here near molar flow. Click on molar flow. Okay. So I'll click on molar flow. Okay, and I'll click add again. And I'll close the window. Now here is showing that there is different variable. Okay, there is one of them is independent and one of them is not independent or it's dependent. Okay, now the temperature is the independent. When I'm changing temperature, it will affect the molar flow. Okay, but not changing the molar flow will affect the temperature. So the temperature is the independent variable and the molar flow depend on it. Okay, the temperature is depending, the molar flow is depending on this temperature. So now he's giving me that I have to give him the low bound and the high bound for this study. I have to give him the low bound and high bound, the range of this study. Okay, now I'll give him that the low bound of this study is -20 Celsius and the high bound is 20 Celsius. And the step size is, maybe I can use 1. Okay, now he will go -20, -19, -18, -17, and so on. Because I said here that step size is 1. Okay, so he will give me on each temperature, he will give me a flow rate of this stream, liquid stream. Okay, within this range. Now I'm ready. I can press run. Now I'm ready. I can press run. After completing, he will give me this message. He is saying me success. Now he's saying success. Okay. Now I need to know what he did exactly. Now I need to know exactly. So I'll go to results. I'll go to results. I can see here the table. Maybe it's better to select transpose table. Maybe it's better to select not the table. I have to select transpose table. It's more. Here I can find on each temperature the liquid flow rate. Okay. I don't need table. I need a plot. I need a curve. So I can press results plot. I can press results plot to see the effect of changing the temperature on the molar flow rate of the liquid on the graph. As you see here, and as you said, that when decreasing or when increasing temperature, the liquid flow rate will start to decrease. Okay, as you see here, at negative 20 or negative 15, it will all, the stream will be all liquid. Okay, and then it will start to vaporize, so the liquid will decrease. Okay, and there will be no liquid at around 14 degrees Celsius. There will be no liquid on the 14 degrees Celsius. Okay, so now as you are seeing that it's simple case, that I can simulate and doing a case study. Case study is one of the powerful tools I can use in the HYSYS, not only in this simple case, but also I can use it in much bigger cases. Okay, I can use it in dehydration, I can use it in reaction, I can see in reactors, for example, I can see the effect of changing the temperature of reactor of the conversion. Okay, some reactions, when I increase the temperature, the reaction rate will increase, and some others doing the reverse. Okay, so I can study the effect or the behavior or of the process by this case study. Okay, now it's the end of the session. So I okay, I can now save this case by from this bottom or by clicking file and then save as. Okay, it anywhere. Okay, it's better to make a folder on your desktop or any other drive and make it like a HYSYS online course and save each case. Okay, now I'll save it. I prefer to save it in different folder rather than Aspen folder. Okay, you can save it anywhere, not in Aspen folder. Okay, okay, we'll see how to in another session. Okay, now it's the end of the session. Okay, so I'll tell you about the next session tomorrow. Okay, I'll tell you. It's not tomorrow. It may be not tomorrow, but I'll tell you tomorrow morning will be the next session. As I'm now outside of Egypt, so maybe sometimes I'll not. It's not easy to me to sit for 1 or 2 hours and giving this lecture. So I'll tell you about the next session tomorrow, inshallah. Have a nice day, and please, if you have any question, you can leave it on the event, or you can join this group. Okay, you can wait. You can wait. I'll send you a group. You can join it, and I'll send now. I'll send you now a link of the group. You can join it, all of you, and it will be for us to share any files or for you to ask any question, and I will try to answer you. Okay, so I'll send you a link now. You can wait, and I will send the link. Okay, I'll stop only the screen sharing, but I'll send you a link now. I'll send you a link. Okay, you can join this link. You can find that this group, HYSYS online group. Okay, you can join this group. I'll confirm this your requests. Okay, if you need any question, you can ask here. Okay, for this recording, uh, I'll not promise you, but I'll try to do my best to upload. I'll try to do my best to upload. Okay, okay. Uh, nice to see you all, and we will keep in touch in this. And you can follow me and know the next session on the event. Okay.